absolutely deafening. There's over 100,000 city terns here, and they are just defecating everywhere. It's a huge amount of nutrients being put here.
In the middle of the Pacific Ocean is Palmyra Atoll, a cluster of islands that are furthest from any landmass on Earth. It is home to hundreds of thousands of seabirds, untouched coral reefs, a fish population that is 44% sharks, and the largest crab species on Earth. Because the atoll is extremely remote and has no permanent inhabitants, it is a prime location to sample mycorrhizal biodiversity. Mycorrhizae are a type of fungi that form networks underground and provide nutrients to plants. These fungi are thought to be especially important in helping forests survive on tough coral soils. The remote and fragile nature of these islands means that scientists have to be extremely careful about keeping out non-native plants and insects. Scientists are required to get special permits and freeze their clothes every day before stepping onto the small islands that surround the landing strip. After 2 years of planning, we set out to examine the role played by mycorrhizal fungi in this delicate ecosystem. Until now, the mycorrhizal fungi of the atoll have never been studied, but scientists are increasingly interested in how fungi can help restore the rainforest ecosystems of the atoll. Despite being so remote, the island ecosystem is threatened by invasive coconut palms, which were introduced in the 1850s, followed by black rats, likely when the islands were used as a military base in World War II. To stop their spread and restore the atoll's native rainforest ecosystem, the Nature Conservancy, U.S. Fish and Wildlife Service, and Island Conservation have actively removed over 1 million non-native palms and fully eradicated the black rats. By eradicating palms, scientists are hoping that the native Pisonia forest will rebound. Pisonia is a keystone species on Palmyra because it provides critical nesting ground for the massive seabird populations. Seabirds, which nest in native Pisonia trees, generate massive amounts of nutrient-rich guano that enriches the hard coral soils. Now researchers want to understand how mycorrhizal fungi help capture the rich nutrients from the bird guano and release it to the trees. The trees are making their own soils because organic matter gets stuck in these pockets, and then the roots come back into the pockets themselves and start feeding off the organic matter that they've captured. So it's like the tree is building its own soil with the fungi on these islands. SPUN is working with the Nature Conservancy to systematically sample mycorrhizal fungi across 27 of the islets, avoiding populations of small reef shark that roam between the islands.
I got bumped by the shark!
When the rats were eradicated, the crab populations began to boom. Coconut crabs live to be over 60, hunt, and can even climb trees. They molt underground, and so sampling for soil has to be done very carefully.
So on all of these islands, there's huge crab activity. There's about 15 species of crabs here, and they're constantly turning over the soil. And one idea we think might be going on is that they help spread the fungi to new roots within the tree system.
Researchers are especially interested in understanding nutrient cycling between rainforests and reefs on Palmyra. They're exploring how mycorrhizal fungi may mediate the capture and spread of nutrients from bird guano into marine habitats. Like most ecosystems, Palmyra is threatened by climate change. As sea levels around the islands rise, erosion is beginning to eat away at the coral shores. Reefs help protect the island from rising ocean levels, but sometimes big storms surge and push through.
So there was a big washover, meaning that the sea levels were getting higher and they came onto land. And you can see that it destroyed these really tall Pisonia trees that have been helping the birds nesting. But now these trees are not doing well.
Understanding how mycorrhizal networks function in isolated, remote islands like Palmyra give us baseline data on their importance and the role they may play in future restoration efforts. We show in the paper that Pisonia trees, which are so crucial to the functioning of the whole ecosystem, are dependent on a group of mycorrhizal fungi called Tomentella. Our analysis revealed where these fungi are most abundant across the atoll and where they're lacking. This is crucial knowledge that can be used to better leverage fungi to restore this unique ecosystem.
If there is a tsunami, this is when we'd have to run or walk very fast to the tsunami bunker that's on the other side of the island.